Normally I'm going to check my triangle. I'm going to make sure that it's side-side angle to make sure that I could even have more than one. But if I'm telling you to determine the number of triangles, you can pretty much assume that I'm telling you it's side-side angle. All right? You can pretty much assume that because I'm not going to ask you how many there are if I have side angle side, because there can only be one as soon as you see side angle side. So this right here automatically tells you that you're going to be using that side-side angle stuff. And in order to do that, we're going to start by drawing our angle first. So we just draw our angle. That was given to us. Doesn't matter how big or small we make it. And I'm going to put that 41.2 degrees. And we can see that's alpha. So that means this is angle A. Which means over here is going to be our dangling arm. We don't know how far that's going to go. So we're just going to leave it as a dangling arm. That is our side A. Well, that's 8.1. The only other side they give me is 10.6. That is going to be right here, all right? Don't try to put it here because you can't solve it. You have to put it right there. So every time I'm doing a problem like this that's determining the number of triangles, I should automatically have this set up. Where I have an angle, I have side, side. So side, side, angle. All right, now all I have to do is decide how many triangles that I can actually form. Maybe I'll label this as C. Our B, we don't know where it is. It could be here. We could have two of them. We could have none of them. We'll see what we have. So my very first check is I'm going to ask myself, is my dangling arm longer than my fixed arm? Is this arm longer than this arm? No, it's not. So it's not number 4. It's not number 4. So that automatically discounts number 4. So if I can't use number 4, I'm going to go ahead and say I need to find the height. If this would have been longer, you would have been done. You would have said 1 triangle, and you wouldn't have to do any work whatsoever. You could just say, hey, A is bigger than B. I'm done. There's 1 triangle, Mr. Pavian. All right. Unfortunately, that wasn't the case, so we need to find that height. And we're going to note, once again, that this is a right triangle that's formed by the height. So we can use SOHCAHTOA. Now, which one am I going to use if I want to have an opposite and a hypotenuse involved? Am I going to use sine, cosine, or tangent? I'm going to use sine. Yep. So we're going to use sine of 41.2 degrees is going to equal the opposite, which is our h, over our hypotenuse, which is 10.6. Which I multiply both sides by 10.6. So you should have came up with h equals 10.6 times sine of 41.2 degrees. And so our h is going to be about, or it was it equal to, no, it was about 7, right? About equal to 7. So that means my dangly arm is longer than my height. How many triangles do I have? What was that? I got 2 of them. And that's because our A is bigger than our H. And so that's going to be 2. I got 2 triangles. Are we good on that? Are we good on just figuring out how many triangles something has? Okay, so that's one of the most important things. The other thing that might show up on the test is possibly finding the area of a triangle. And that just involves us basically finding this height. Okay? But that being said, what questions do we have on the homework? Because I know those were tougher problems. Yeah. I'm going to go ahead and draw that picture. So this could be something I put on the test. So it's a good question to ask. You could be almost 100% certain I wouldn't put this one on. It's just too much information. It'd be like 1 question, and I'd have to assume it takes you like 20 minutes to do it if you mess stuff up. So this would be something I could put on the test, though. So I'm just going to draw my picture of my triangle. And let's go ahead and label it A, B, C. Well, we know A is going to be 12.9. Side B is going to be 6.4. And we know that, remember that's gamma. That's gamma. So this is going to be angle C. So angle C is 13.7 degrees. What I need is I need a base and I need a hypotenuse. All right? Our height. We need a height and a base. All right? The only time I can find a height is if I'm given an angle, because then we can use sine, cosine. Most likely we're going to use sine. So we're going to look here, and I'm going to look. If you look at that dashed line I'm drawing, that is going to be a height. And if this is my height, that's my base. All right? And how do I find this height again? Sarah?
Okay. Do like sine 13.7.
Yep. Which is height over hypotenuse.
Yes,
And now we'll get you your value for h. Okay, so our base was 6.4, and then we just got to solve for h. Jeffrey, is that enough? Yep. Okay. So I'm glad you asked that one, because that can be something that can show up on the test. Because that isn't, once I went over it, it's not a hard problem, right? It's stuff that we can all do. It's just whether you could see your way through it. All right, other questions? Yeah, Alex.
41.
Oh, 21. So that's kind of the same thing, except we got to do a little bit extra work. So this base may not have been all of the space you needed. So we're going to say that's A. Let's say that's B. Let's say that's C. So our alpha is going to be 39.4 degrees. Our B is going to be 12.6. And our A is going to be 13.7. What do we notice about what's given to us? Our two angles given to us. Mike? Do you have a question? Oh, okay.
I just drew the triangle differently. Now I see what I'm supposed to do.
Okay, so this is side-side angle, so we would have to figure out how many triangles there are. And it's only going to be, so this is technically my dangling arm. So once I saw this, I'd been like, okay, it's side-side angle. All right, so that would have told me, and I probably would have did this in my head, and I'd have been correct. Because I would have drawn it like that. That's my dangling arm. My dangling arm is going to be 13.7. This is 12.6. This is 39.4 degrees. If you did your very first check, is A bigger than B? So how many triangles can we have? So this was actually correct to start off with. This was correct to start off with. I can draw a hypotenuse that can get me my other side as well.
So I guess say that wasn't possible. How would we find the base?
You're with Mrs. Okay, that's fine. How would we find the base if this wasn't written?
Or like, say we didn't know E was larger, or say like A wasn't larger than B. How would we find the base?
We would have to find both triangles, find both bases. You can assume I'm not going to put that on a test, because that would be all of the steps of 15 plus finding area of both of those triangles. So if I ever gave you something like this, all right, I might give you bonus points for recognizing that, hey, it could have been multiple things. But if I gave you one like this, you can assume it's going to be one triangle. It's just going to be one triangle. Either it's going to be a right triangle or it's going to be something like this. Now, something like this, we could find this here to get our base, but if you're smart, you would have just, not smart, but if you just saw the trick here, I would have drawn my height here. That means I can find this h, and this would be my base.
How could you find that H?
I got this guy.
Where you don't have the AB value.
Oh, I don't. You know, I was going to divide it in half. No, that was not going to work. That is not going to work. You do have to find this missing side. You do have to find that missing side. I was trying to shortcut that. That is not going to work. So you would have to find that missing side. But that isn't so bad because it's just a missing side. It's just going to be, well, C. So all we're going to do is we're just going to find our given angle here. So if I'm looking for an angle, I'd be like sine of B over side B, which is 12.6. That's going to equal my sine of 39.4 over the corresponding side, which is 13.7. And you do that, and you'd get the degree measure of B. I'm not sure what that comes out to. All right, did anyone do this correctly? I don't remember.
35.7.
35.7?
Yeah.
So that comes out to 35.7 degrees. All right, so 35.7 degrees is going to get us to angle C, right? Because we can do 180 minus this minus that, and that will get us to this side. Does that make sense, or is the numbers not coming out?
Calculator, I get 0.5.
Are you getting... Did you do the sine inverse?
No.
Because remember, you'd get sine B
Yeah,
equals some number. I would need to do the sine inverse of both sides,
Okay, yeah.
and that would come out with the degree.
Mhm.
Yep. I'm assuming that people that aren't writing it down got it right. I'm hoping, or you looked it up, and that's what I'm hoping. Yeah.
So can we just, excuse me, could we just draw a line down the middle, so that's height, then use sine to find that line? Then use the Pythagorean theorem to find half of C, and multiply it, that half of C by the height.
Hold on. Can shh. I want to think through what you said. So you said just draw a line down the middle,
Right, then we use sine.
and you can find height.
Find height. Then we use the Pythagorean theorem to find half of C, and then we multiply it.
Well,
C by
the only thing is we don't know this is half. This is only half of an isosceles. This is the exact same thing I almost told him to do, that Alex to do. I was just like, if we draw that, then we know half, but it's not half. It's only half if it's an isosceles triangle, and in fact, it's not an isosceles triangle. So we could find this side, but we'd be missing this side until we found that. That makes sense, though? Yeah. But actually, once you get this degree measure, you can use your height to figure out that using the Pythagorean theorem too. The easiest thing to do on these is just make sure you solve the triangle. All right, if it's side-side angle, solve the triangle, and that will get you your height and stuff. So what I'd probably do on the test is I would put on here solve the triangle and find the area. All right, if I had a problem like this. If it was something like this, I'd probably just say find the area. That should be kind of your sign that I gave you enough information to find it. Or if I put solve the triangle, it's basically telling you, hey, I need to find all your sides and angles to actually do that. Okay? So I'll try to help you on the test to know what you need to do. All right? Does that answer your question, Alex? Is that good, Alex?
Yeah.
Yeah. You sure?
Yeah. I guess for now. I don't know. Oh, no, yeah, it does.
Okay. All right, other questions from the homework? Yeah. Number 27, was that the last one? So that was kind of a challenge question. So what you needed to do is you needed to divide this into two triangles. The first triangle is pretty easy because I'm going to find the area of this first triangle, which is half the base times the height. We can find the height because I know this is 45 degrees, right? Does that make sense how we can find this height? The harder one is this guy here. And that's because if I draw a height here, I really don't know this angle measure. So the trick to this one is you needed to, this is way back in geometry, is you needed to kind of extend this line. And then you draw a height here. That's 90 degrees. Well, if this is 120, this angle here is going to be 60 degrees. And that would give me my height. Okay? Knowing that this is 4, hypotenuse is 4 still. Hypotenuse is still 4. So it's sine of 60 equals h over 4. We solve for h, and then it's half of 10 times that number. All right, so the whole trick to that one was dividing in triangles and realizing that I can actually find this height. That is okay. That's the height of a triangle. It looks weird, and it's been a while probably since you've done that, but you can do this. That was the trick to that one. Okay? Are we good on those otherwise? Okay. Then let's go over to today's assignment, which is applications. Now with the applications, remember there's no harm in looking at the answer key to make sure you understand what they're asking you. All right? Because a lot of these are like, I'm connecting a pole to something on the ground. And you're just like, I'm not sure what picture I'm looking for. That's a good time to look at the answer guide to make sure your drawing is correct before you do all the math. Take like 20 minutes doing the math and then find out your drawing was wrong to begin with. Because there's nothing more infuriating than solving a problem that you weren't even solving correctly from the beginning. So the first thing we're going to talk about are bearings. Let me look real quick. So yeah, like the surveyor, this one's going to be a bearing question. So this one might be a good one to, kind of look in the answer guide to make sure you're even setting up correctly. This is more like the next one. Let me just look which ones we got. That one's more drawn for you, and this one's drawn for you as well. So really, we're going to do a problem just like this one. We're going to do a problem kind of like this one. So hopefully you can relate the two. All right. Bearings. In short, what a bearing is if we picture a compass on a map. If I picture a compass on a map, we have north, we have east, we have south, we have west. What bearing is how far away you are from north. So if I have a 30-degree bearing, I'm going to go 30 degrees clockwise, and that's the direction I'm heading. So that's a 30-degree bearing. Just like if it's 60 degrees bearing, you're going to rotate 60 degrees, and that's why we're pointing more towards east. That's why it's north 60 degrees east, because we're going northeast, right? If you can picture it, that's 60 degrees. So that's all bearing is how far away you're going from north, and it's always clockwise, and so you can keep going up. It could be 270 degrees. You just know you have to draw this to 270 degrees. Okay, so that is what bearings are. We need to use that information in the next one because we're going to talk a lot about bearing. So a plane left Ada and flew 100 miles towards Bern on a course with a bearing of 18 degrees. So if we look at that compass I drew, so if I can, what they're saying is their bearing is 18 degrees. So that right there would be 18 degrees. So what I'm going to kind of do is I'm going to kind of translate that down here. I'm going to put a little line pointing to north. So that's north. This is just to help me draw it as correctly as possible. And I'm going to say Ada's right here. I'm going to call it A for Ada. I'm gonna shift this up a little bit. I don't know why I wrote it so low. I'm going to shift it up just a little bit. We'll put it there. Okay, so that's Ada, and that's true north. Well, we didn't go true north. We went 18 degrees away from true north. And so that's 18 degrees. And then we reached Bern. Well, I'm going to call Bern B. And that was 100 miles. So we traveled 100 miles, and we got to Bern. All right, once we got to Bern, he flew due east, which is a bearing of 90 degrees. So he's going straight east, which is also called a 90-degree bearing, because if you picture 90 degrees off, yeah, I'm going due east. So we're just going to draw a straight line due east. And he's going to reach Cairo, which I'm going to call C. Huh, a triangle named ABC. Actually, the first time you've seen that. All right, and then he returns to Ada in a bearing of 225 degrees. So he's going to return to his starting point at a bearing of 225 degrees. That means if I was looking at a compass that pointed me north here, he would have traveled 225 degrees bearing. That's a 225 degree bearing. It says find the maximum distance the plane was from Ada. So at what point on there, is it B or C, that he's the furthest away from A? Jack. It's going to be C. So all I'm looking for is this distance here. I'm looking for B. But we don't have a bunch of information yet. In fact, the only thing we know about the triangle is 100. We have nothing else inside of here. So let's work our way through this. Well, this is a right angle, right? So that's 90 degrees. This right here, let's put it in green. This right here is a right angle, so that's 90 degrees. So if that's 90 degrees, can someone tell me what is the measure of this angle if that's 90 degrees? What do you got?
45.
You got 45? That's what I got. So either we're both wrong. We'll go down together. I need one more angle. This is a very tough angle to get. Do you see it? It looks like it, except we don't know. We don't know how much this is the right angle. If we knew this was here and this was like 20 or something, then we could get angle A. In fact, it's not angle A. We can't quite get angle A. It's going to have something to do with B.
Can you like make another triangle on the left side and actually we can find it?
It's possible. It's possible. And in fact,
Then you would have a right angle up there, and then you could do 180 minus 90 plus 18. And then you could find, and then you would do 180 minus that final angle, and then you could find that.
let's see if that works. Let's see if it works.
Okay, so 72 minus 180 would be the angle B. That's what we did. So 108.
108?
I think so. If I did the
You
math
think so?
correctly.
That is in fact 100% correct. I didn't even see that one. I made it a little more difficult. So Jack is 100% correct. That was awesome. All Jack said is let's extend this line. Let's extend this line. That makes a right angle. So that's 90. That's 90 degrees. So that would make this 72 degrees here, which would make this 108 degrees. I like that method a lot better than my method. My method was, well, they're similar, I guess. Let's just stick with that one. Let's not do mine. Mine is going to throw more confusion into it, because we already have this written down. That works out great. Let's use that. All right, so we have 108 degrees, which makes angle A. Anyone figure out angle A? 27. Cool. So we have three angles. We have a side. I only need two angles and a side actually to find something. I want to find a side. So we're going to use the law of sines. Right? We're going to use the law of sines because that's the only one we know. We're going to use the law of sines because I actually have angle, angle, side, and I have angle, side, angle. I got both of them. Remember, either we need angle, side, angle, or angle, angle, side. Basically, I just need two angles and a side to use law of sines. That's a good thing to remember because we're going to do law of cosines tomorrow, which is a little bit different. So two angles and a side tell you to use Law of sines. Well, law of sines, if I want to find a side, I want to find b, all I'm going to say is, well, b over the sine of 108 has to equal, now I want something that I know the sine and the side and the angle of. Well, I know this side, I know this angle, so we're going to put those two guys together. We're going to say that equals 100 over that sine of 45. And so b is just going to equal the sine of 108 times 100 over the sine of 45 degrees. Can someone tell me what b equals? What do you got? You got 134.5. That's exactly what I got. 134.5 miles. And we're done. Thanks to Jack making this a lot easier. I was going to extend this, use parallel lines. I guess I haven't been teaching geometry too much that I look for the parallel lines. But that makes that problem a lot easier. So we just need to find two angles and a side. So in all these problems, all you're looking for is two angles and a side, because you actually know that third angle every single time. All right, any questions on doing that problem? Okay, the next one was an incredibly hard problem that took a majority of class time to complete last time. This time we're going to do it in under 10 minutes. Okay? And most of it's just me explaining stuff. Alright, so we have an angle of elevation to the top of a tower. Do you remember that tower problem? We'll do the drawing and you'll see it. So we have a tower. We have a tower and we have a point A on the ground that is 19, that forms an angle of 19.9 degrees. So if this is my tower, let's just draw a green tower. We won't get fancy with it, we'll just call it T for tower. That's my tower. All right, we have a point A that's somewhere over here. And the angle of elevation to the top of the tower, so if I string this out and call this point A and form that triangle, that is going to be 19.9 degrees. Now if I move 50 feet in, that's what from point B, 50 feet closer to the tower, the angle of elevation is 21.8 degrees. So if I move 50 feet in, we have some point B that when I stretch this out, reaches the top of the tower, and that has an elevation of 21.8. Remember this problem? Yeah. That took like a full page to even do. Like I think I just gave you a blank page, and we just kind of filled that whole page up. The reason why I didn't stress it too much and I didn't put it on the test is because this is a much easier way to do it. And what we're going to basically do is we're going to use the law of sines to work our way to this fact that this is a right angle. So if we notice, we have two triangles here. I got this skinny triangle, and I got this big triangle here. We're going to focus on this skinny triangle because I want to get this length here. I want to get that length there because if I get that length, I will have an angle, and a side, and I can use law of sines to get to T. So I just need to get to A. Well, to get to A, I need to have two angles and a side. Can we find another angle that's in this triangle here? What do you got, Mike? I can get this angle right here, right? I can do my 180. And I can subtract my 21.8, which should be 158.2. So this is going to be 158.2 degrees, which you could use that to figure out your top one, which was 1.9 degrees. All right, cool. So I have two angles. I have a side. I actually have three angles and a side. And I actually know one of the sides, right? I know this is 50 feet. So we know if I use the law of sines, I can use sine of 1.9 and that side of 50. And I'm looking for a missing side, right? So I'm going to put my sides on top. So if I'm looking for A, I'm just going to say, hey, using the law of sines, A is going to be over the sine of the angle that references it. So we're going to do A over the sine of 19.9 degrees. And that's going to equal, I'm looking for the one that I know the side and the angle of that side. Well, I have 50 feet. I know that angle is 1.9. So we're going to say that's going to equal that 50 feet over that sine of 1.9 degrees. So that means that A is going to equal sine of 19.9 degrees times 50 over sine of 1.9 degrees. Did anyone get A for me? What'd you get?
513.3.
That's exactly what I got. 513.3 feet. All right, so now we know A. Now we know A. You don't have to do this, but I'm going to redraw this triangle really quick with the information I now know. Let me just...
Would we even have to draw the skinnier triangle with it? Did we just draw like a thicker triangle now?
That's all I'm going to do. I'm going to draw, yeah. Yep. The reason why I'm doing this is to keep everything clear of what we did. 0.8 degrees, that's my B. We know that this is 513.3 feet now. I know that this is 90 degrees. Well, the good thing is, I know this angle, and I know this side across from it. So all we're trying to do is find this missing side. Okay, so I'm looking for that missing side. So we use those law of sines, where we put our sides on top. So T will be over sine of 21.8 degrees. And that's going to go ahead and equal, well, that side is 513.3, and it's all over sine of 90 degrees. So that tells me T is going to equal the sine of 21.8 degrees times 513.3 over sine of 90 degrees. And you should have came up with T equaling about... What did that come out to? Because I actually picked a really hard way to get
190.6.
190.6, yeah. I rounded to 191 feet. I don't know why in your class I picked the hard way to do it. What kind of triangle is this? Did we have to use law of sines to find that missing side? Couldn't we have just used SOHCAHTOA? We could have said the sine of 21.8 equals opposite over hypotenuse. Did this work though? This will work on every single triangle. So that proves a good point that even though you could have used sine, cosine, tangent, this works no matter which triangle you have, whether it's right, whether it's oblique, whether it's anything else. So it's almost like, why didn't you teach people this first? I don't know. That I don't know. Okay, so this could have been done with just SOHCAHTOA or sine. So if you did it with sine, good on you. So I know some of you are working ahead of me, which is awesome. That's a good way to do a math class, is try to work ahead and think about what the next step is before I tell you the next step. All right? Any questions about either one of those problems? All right, everyone have a wonderful, wonderful day.
Thank you.